Hey everybody. Okay, building on the nebular theory, right? Okay, we have this theory, the nebular condensation theory. It works really well for explaining our solar system. And it predicts that inside the frost line, if you're closer to the sun than the frost line, then the only thing that can be solid is rock, and therefore you should have terrestrial planets orbiting the sun inside the frost line, which our solar system does. Outside the frost line, you can have ice freeze also, and then you form planets out of rock and ice, and then those big icy cores accrete a bunch of gas out of the disk and form your big Jovian planets, which is what we see in our solar system. What determines where the frost line is? Well, the only thing that really matters is the luminosity of the star. The brighter the star is, the farther away you got to be from it in order for ice to freeze. If you got a dim star, then you got to be closer to it. You can be closer to it and still have ice freeze, because ice molecules or water molecules floating out there in space have a freezing point of 150 Kelvin. So that doesn't change. The luminosity is the only variable in this equation. Everything else is a constant. So for our first example here, let's say you're studying a star that has 7.34 solar luminosities. What is the distance to the frost line around that star? And as I said in the video lecture, I'm not going to use this equation. It's too complicated. That's annoying, right? So all of these constants just boil down to 3.45. So then the distance to the frost line in AU is just 3.45 times the square root of luminosity. Or, like I did here, right, taking the square root is the same as taking something to the 1/2 power. So luminosity to the 1/2 power. Same thing. So, what's the distance to the frost line for this star? Well, I've got my spreadsheet kind of already laid out here. So, all right, if it's a 7.34 solar luminosity star, the distance to the frost line is what? It equals 3.45 times the luminosity to the, I'm not going to say 1/2, I'm just going to say 0.5. That's an easier problem. That's an easier value to deal with. All right, so have I got that right? 3.45 times the times luminosity to the 1/2 power. Looks good to me. Okay, and that is the distance to the frost line in AU. So, all right, water has to be 9.35 AU from the star in order to freeze. So then, now let's say we've discovered 3 planets around this 7 solar luminosity star. Does this solar system, or does this planetary system make sense according to the nebular theory? Let's check, right? So, the planet B, it's 5.4 AU, so that's closer than the frost line. So that's inside the frost line. And the nebular theory would say that, the nebular theory would predict that if you're inside the frost line, then you should form terrestrial planets, and it is terrestrial. Okay, so far so good, check. Planet C is farther than the frost line, and so outside the frost line it's cold enough for ice to freeze, and therefore this is outside the frost line. Cold enough for ice to freeze, you should form Jovian planets, and it is Jovian. Okay. Planet D, also outside the frost line, and also Jovian. Check, check, check. All right. Are all the terrestrial planets inside the frost line? Yes. Are all the Jovian planets outside the frost line? Yes. So is this solar system well explained by the nebular theory? Yes, it is. Okay. What about this one? What about our first practice problem here? This is one of those fainter stars I was talking about, right? A much lower luminosity star than the sun, so you can be closer to it and still have ice freeze. What's the distance to the frost line for that one? Here, I'll move this down so I can look at it and the spreadsheet. All right, if it has a luminosity of 0.0122. Okay, wow. All right, so 0.38 AU is about the distance between the sun and Mercury. So this star is so dim that if you get Mercury's distance away from it, the ice freezes. All right. So what do we get here? What do we expect? Or what are we seeing? We found 4 planets around this star. What do we see? Planet B is closer to the star than the frost line is, so that's inside the frost line. Planet C, also inside the frost line. Planet D, also inside the frost line. Planet E, oh, just inside the frost line. Okay. So, the nebular theory predicts that you should find terrestrial planets inside the frost line and Jovian planets outside the frost line. So something funny's going on there, right? You know, here, planet B, that's fine, but we've got 3 Jovian planets inside the frost line. Well, that's not what the nebular theory predicts. Okay. What about this one here? It's 3.57 solar luminosities, so that's 6.52 AU. All right. So that one's really close, right? That planet's orbiting really close to its star. So that's inside the frost line, right? 0.8, that's inside the frost line. 2, that's inside the frost line. 5, still inside the frost line. Again, we got 4 Jovian planets all inside the frost line. Well, gosh. The nebular theory says that Jovian planets should form only outside the frost line. And yet we're finding a whole bunch of these Jovian planets closer to their stars than should seem possible. So is the nebular theory just wrong? Should we just throw it out and come up with something new? Well, let's keep working here. See what it looks like. All right. 0.822. All right, that's 3.13. All right. So again, that's inside. All right, so those are all inside the frost line. All 3 of them are terrestrial. All 3 of them are inside the frost line, just like the nebular theory predicts. Okay, so this one's making sense. All right. So maybe the nebular theory isn't totally wrong. Maybe we don't need to chuck it out and come up with something from whole cloth. How about this last one here? 0.013 solar luminosities. 0.39 AU. Again, pretty close. Okay, so that's inside. Are you sensing that a lot of these planets are really close to their stars? Yeah, they are. We're going to start talking about how these exoplanets are found next. But the short version is the reason why we're finding so many planets so close to their stars is that they're easier to find. So since it's a lot easier to find planets close to the stars than far away, consequently we're finding a lot of them. So that's a look ahead at what we're going to be talking about shortly. Does this solar system make sense according to the nebular theory? Yeah, all the terrestrial planets, they're all inside the frost line. Okay, that's pretty good then. All right. Well, seems like all hope is not lost, right? We got 2 systems, or three systems if you count the first one, that do follow the nebula theory and 2 that don't. So what is that telling us? Well, it's telling us that the nebula theory is clearly not the whole answer. The nebula theory works great for explaining our solar system. It works well for explaining 3 of these other systems. But we've found a whole bunch of these Jovian planets orbiting close to the stars, orbiting inside the frost line. So the nebula theory is not a completely solved problem. Well, no theory is, right? This is the exciting thing, is that when you discover something new and surprising, it makes you realize, oh, we don't have the whole answer. Well, okay, how do we go about answering that? How do we go about solving the mystery of these Jovian planets orbiting inside the frost line? Well, when we study how we discover these exoplanets, then hopefully we can find some clues that'll give us the answer to that. But I'll leave that for tomorrow. All right. I hope this is making sense. If you're confused, then go ahead and post the questions to the discussion board. Otherwise, great. Move on to the next topic. See you later.